Hello, I'm Anna McKie, and in this video, let's have a look at doing compound interest using the formula. This is before we get to the graphics calculator. And the previous video was using a table so that you could understand the connection between simple interest and compound interest. So go back and have a look at that one if you're brand new to this. So the formula, and this is the formula that's going on inside your graphics calculator when you come to that. So to find f of v, given p of v. So what are those if you're not familiar with them? Having a look down the bottom here, f of v is the future value. So if we're trying to find that, the amount of money in the future, so we invest an amount to start with, p of v, the principal value. And then the other letters to be familiar with are I, the rate of interest per period in decimal form. And so that's where we divide by 100. And n is the total number of compound periods. Probably worth me saying this one a couple of times. So if it was monthly, that's 12 times in each year for 3 years, that would be our n. And so the frequency comes first and the number of years comes second. So the formula is, make sure you've written this one down, the f of v, the future value, is the principal multiplied by this, which is essentially, so it's a multiplier where it's 1 and we're adding on that percent of interest, and to the power of n, which is the number of compound periods. If you actually are given the future value and you need to backtrack and work out the principal value that you need to start with to end up with that in the future, this is just a rearrangement. As you can see from the first formula, it's dividing through, but it's probably worth having that written down somewhere. So let's do a couple of examples. When doing one of these questions, I like to write down the numbers as I go, as opposed to working through the whole problem, but you do what works for you. So let's read it a bit at a time. A couple saving for a boat have savings of $15,000. So we could stop there. $15,000 is how much they have to start with. Which letter is that one? That's their principal value. PV is 15,000. You don't necessarily have to write the dollar sign. In an account that pays an interest rate, so the 4.5% PA. So this is our I, and it's 4.5%. But just a little reminder there that we divide by 100, and that gives us 0.045. How much, and PA is per annum, Latin for per year. How much will they have in the account after 3 years if interest is compounded annually? So that's for part A. So this is our N now. And so we look at how often. The first one is annually. As you can see, part B is quarterly. So if annually, how many times a year does that happen? Once per year. For how many years? 3 years. So our N is going to be 3. So let's use our formula. Let's write that out. Substitute in the values that we have. Our principal is 15,000. 1 plus 0.045 to the power of 3. And working that out in dollars is $17,117.49. So that's how much they end up with if it's compounded annually. Quarterly, what do you anticipate will happen? Will the number be the same, bigger or smaller? So quarterly, that's compounded then more often, 4 times a year. So writing out our similar values, well, do you know what? Actually, I don't need to write my P and my I, really, do I? Because they're staying the same. The N changes. How many times a year? 4. By how many years? 3. So our N is 12. So let's write that into our formula. Putting that to the power of 12, working that out. You don't technically need a graphics calculator to work this one out. It's $17,155.12. What do you notice? Is one bigger than the other? Yes, this one is, the quarterly. And so that's what we expect to happen. If you compound interest more often, you end up with more interest. So something to note there. Let's do one more together. 3 years ago, Holly invested an amount of money in an account paying 6.2% interest compounded annually. We could stop there before we've read any more of the question. This is, well, we've got our N and our I there. Our I, the 6.2%, is also equal to 0.062. N is compounded annually, so that is once a year. And for how many years? It says it right at the beginning of the question, 3. It says it in words though, not as a number. And So 3 years ago she invested this, and now it's worth this much. That's our future value. That's not our principal amount, because that's what it's asking us in the question. How much did Holly invest? So our future value is the 5497.77. And so we have to rearrange this equation to work out how much did she start with and put in to get that much back. So write out the formula. I've decided to use that formula just to show you the algebra in case you need a little bit of a refresher on what to do there. We're solving for the principal, and so we're dividing through by this part of the equation. And let's substitute in our numbers now. Our future value is the 5,497.77 over 1 plus 0.062 to the power of 3, and that works out to be $4,590. So that's how much she started with to end up with the $5,000 amount down the track. All right, there's some examples to do. Follow me in the next video for when we work through doing these compound interest questions with a graphics calculator. Thank you.